Hi guys, so in these series of tutorials we're going to perform RAG, which is a retrieval augmented generation, and we're going to set up this on GCP infrastructure, and the reason being because there's a little bit of LLMOps here, and it's easy to set up a RAG architecture in your local environment, but when you set up this thing in cloud, that's a little bit of industry focused thing. So we're going to do this whole setup in which we will be having a small LLM. We're actually going to use Gemini, and from there we're going to perform RAG, in which we would be having some external document that we would be giving to the Gemini, and then we're going to perform RAG thing as well. So let's begin this thing, and let me explain to you guys like what RAG is in the first place. So RAG is a traditional technique, not a traditional, maybe new one now you could say, but it's a technique that enhances the LLMs by incorporating external knowledge. So if you guys know the difference in between, let's say, ChatGPT and Copilot, or maybe Perplexity AI, one of the differences that you would see is, well, obviously, ChatGPT is more static. So basically, it would give you answer based on the knowledge that it would already have. While Copilot and Perplexity AI, so these are some of the other also LLMs, but what they do is they would give you answers based on some information that's present in the like in the internet, for example, or they do some sort of like Google search or Bing search, and then you get the response from there. So those things, Copilot and Perplexity AI, they are kind of a RAG system. They're not just LLMs because they don't rely on their internal knowledge. They actually go out and retrieve knowledge, and then from that knowledge they generate responses. So they are RAG because in this case we are retrieving a context, and we are augmenting that context into our LLM, and then we are asking the LLM to produce some results. So we get the answers to it. So that's actually a RAG. Basically, we take bunch of context, we give it to the LLM, and we ask some query, and we want the LLM to reply to us based on that, based on the context and the query. So that's that's how the LLM work. Obviously, you increase the the ability of your traditional LLM. Not just that, you can also provide sources. You also don't need to train your LLM onto the new knowledge. So these are some of the benefits as well, and obviously it's quick and easy to set up, so you don't have to do much of the work. So yeah, that's that's how the LLM works. So obviously an LLM would have a retrieval module and then a generator module. So retrieval would be the one that would be bringing the external context, and generator module would be the one that would provide us the generated output based on the context that we got, right? The retriever fetches relevant information from external databases or knowledge bases. This retrieved information is then provided to the LLM as a context, and that would be along with the user query, and then we would get the response. So the same thing that I've talked, this is the figure that you see here, in which we give bunch of documents. We this is how basically this is how traditionally any LLM is set up, and this is a very high level overview of how LLM is set up, right? So first of all, you'll have bunch of documents. This would be, let's say if you are building a let's say if you are running some some legal industry, and you have lots of legal documents. So one of the and you want a user you want to build a chatbot that would reply to users' queries based on the knowledge from those documents. So instead of going ahead and training your whole LLM onto those documents, you can instead of doing that, you can have something like a RAG that would do the same work. So let's see how it works. So first of all, you'll have lots of documents, obviously, or you could have like one document, or you could have hundreds of documents, doesn't matter. You're going to take these documents and you would be creating embeddings out of those models. So basically you will be passing these documents through a model that would create embeddings of each of those documents, and not just that, but it might even create embedding of maybe different chunks inside those documents. Then we're going to store these embeddings into a vector store. So vector store is basically a database to store records as vectors. And the benefit of having a vector store is basically you can perform a semantic search. So you can have a query, or you can let's say if a vector store has lots of embeddings inside, so then in that case you can send an embedding, an external embedding, and you can calculate or find the closest neighbors to the embedding that you have sent inside. So this is again just like a regular database. You can have a vector store, but the benefit is that, as I said before, semantic search. Now, if you guys know at least a little bit of NLP, you might know what's a semantic search. So I'm not going to explain that in this video. So, but in general, vector stores help you to perform semantic search on a given query, let's say. Okay. So this would be the first part, in which we would be creating embeddings of our documents, and we'll be storing them in a vector store. Now, and again, that would be, you could say, a static part as well. As for the dynamic part, which would be the user interface and the way in which we would be setting up the user the everything that's connected to the user basically. So let's say you have an application in here. That application is making a query request. So let's say if you have built a chatbot and a user is writing a query. Let's say if you have a legal documents, then in that case user would be asking some questions about those documents. In that case, you would take that query and you would send that to the same embedding model, and you're going to create an embedding. Once that's done, you would take that take that embedding, and you would find all the nearest neighbors to that embedding in the vector store. Let's say if you found 5 to 10 nearest neighbors, then you're going to take that query and you're going to take the nearest neighbors, and you would send them to the LLM, and you would say that give me the answer to this query based on the given context from here. You would send that to the LLM, and then you would get the output, which would be based on the context that's given here. This is very high level overview of how RAGs work. Obviously, you can have additional things that you can add into this, like you could make your model like multimodal, as in you could have multiple types of inputs that you can provide. You can also make this more of a recommendation engine kind of thing. But again, like those things are for sometimes in the future we might touch those things. But yeah, this is how a traditional LLM works. It's very simple. Basically, you provide context to your query and you give that to LLM, and then ask the LLM to provide you the output based on that context. Okay. In this tutorials that we're going to have after this, in those tutorials, this is the architecture we're going to use. And again, as you can see, it has everything on a GCP. So first of all, we'll be having documents. We would store them in a cloud storage, or we can also store them outside, doesn't matter. But we would be sending them into document AI. This is again GCP native service that helps us to parse those these documents and produce chunks out of those documents. Then we're going to send those chunks, and we would be creating embeddings. So GCP also provides, by the way, some embeddings model. So basically, they take input as a text and they give embeddings out. So we're going to create embeddings of all those chunks that will be produced from the documents, and we would be storing all those embeddings into this vector search AI. Again, this is also a GCP service in which that comes under Vertex AI. So yeah, in vector search, we're going to store all of our embeddings, and that would be the static part. As for the dynamic, we'll have the user part, in which we would be having we would be making a query, and that query would be sent to this model, and from there we would be getting the embedding of our query, which we would be sending inside vector search, and we would be finding nearest neighbors to that query. In our case, we are going to find at least 3 neighbors, and then we would be sending the from here. By the way, we need to convert our embeddings of those neighbors and also the query back into the text, right? So we would also send it here, and then the results that we would be getting, which we would be giving to the LLM. So yeah, the result and the query, we would be sending them to our Gemini model, and we would be asking the Gemini model to generate a response based on these things, and not just from the internal knowledge. And then from there we will be having a response from Gemini, and that would complete our RAG cycle. So this is what this is the whole setup that we're going to do in the coming tutorials. And yeah, see you guys in the next tutorial. Thanks so much.